Hello, my name is Igor and welcome in my workshop. I'm the founder of Filament Design, company designing do-it-yourself devices for beginners, easy to assemble, very accessible and based on 3D printing. Today I will show a few of them. One of them is the device turning plastic bottles into material for 3D printing. So let's take a closer look on it. So general build is very simple. Most of the parts, as you can see, are 3D printed. Electronic parts are easy to get. You can see temperature controller in here. Here is a PWM controller to control the speed of the spool. There are two methods to cut the bottles. One of them is cutting module you see here. You just attach the bottle on it, pass the strip through the nozzle, and the machine is pulling and cutting in the same time. The second method is manual cutter. So you can do the same, but you use your hand to pull the strip. So now I will show you the whole process, whole protruding process. But first we have to prepare the bottle. To prepare a bottle, we have to remove the label, remove the residue of the glue with acetone, then inflate the bottle and smooth the wall surface to remove any fluctuations, so it will be much easier to cut it. To inflate the bottle, I'm using special cap with a valve, installed valve. It's like normal tire valve. I'm closing the bottle and I'm using air compressor to inflate it, but you can use as well normal hand pump, but it will take a little bit longer. Three atmospheres should work. Now I will use acetone to remove residue of the glue. I will use heat gun to reshape the bottle. Pay attention. It's bottle before reshaping with hot air. And now our bottle is totally straight. After 1-2 minutes, when bottle will cool down a little bit, we deflate the bottle. And now we can cut it. To do this, we will need hobby knife. Just simply cut off the bottom of the bottle. Don't have to make it super clean, because we will use scissors now. So we will prepare the strip using manual cutter. I will prepare the edge. It's really important step. A lot of people starting with PETmachine have big problem with it, because when you leave small hooks or not clean edges, those parts will significantly increase possibility to snap later when you're pulling the strip. So, not yet. We have to check the bottle wall thickness, because the thicker the wall, then lower the strip. This bottle wall has 0.15 millimeter. So according to this, I have to choose 10 millimeter strip height. Because you have channels here, you can choose one of the 5 or 6 channels. 6 channels, and depends on the bottle wall thickness, you choose proper one. There is a table showing which size you should choose. And now we are just pulling the strip. Now we have waste. From waste we can't use the bottleneck, but we have a strip. Now we can wind it on the smaller spool. Now the strip is winded on the small spool. We put on the cover to prevent unwinding, and it's ready to install in the PETmachine. When we install our small spool with winded strip on PETmachine, we have to pass it through the guider, then pass it through the cold nozzle. It's really important. A lot of people have this problem that they pass the strip to the hot nozzle and it's shrinking fast, and it's mission impossible then. So when it's loaded, we have to pull it a little bit more and then turn on the machine. When temperature will reach 100 degrees, I will pull it a little bit more, then attach this string that is already installed in a spool and pull the strip through the nozzle. It's a modified nozzle with diameter of 1.7 millimeter, so it's giving a shape, like straw shape, to filament, and thanks to this we can use it later in our 3D printer. On the filament rod there is a fan cooling freshly formed filament and Renault sensor system that detects filament, and when we turn it on we can just leave it half unattended, because I don't recommend to leave it fully unattended. It's good to walk around when it's working, and then when filament will finished, I mean the strip will finish, the machine is turning off automatically. So we are pulling a little bit more. It's much easier now when hot end is almost 180 degrees. Oh, this will be enough. But trim the end. It will attach. Attach the normal string to our filament. Now we are slowly pulling the filament. I will show you this closer. Watching this reshaping procedure is really satisfying. When filament is creating tension on the sensor, we can turn it on. And now when strip will finish, machine will automatically turn it off. And when we decide to use cutting module, we just proceed in the same way with a bottle like with manual cutter. Just the machine will do the hard work for us. I prefer this method. So in the meanwhile, when PETmachine is producing some filament, I would like to say about other aspects of this machine and the whole project. So now it's producing filament with a speed of 1 meter per 1 minute. So it's not super fast. I'm working on the dual nozzle solution, so it's producing 2 times faster. And it's a great, amazing solution in third world countries like Africa or Turkey, where they have a lot of problems with pollution, plastic pollution. They have a lot of bottles that we can find all around on the streets. And for example, in Africa, in Kenya, I have a friend who has 3D printing laboratory, and to buy a filament there, it's a big challenge. First of all, it's super expensive. 1 kilogram of PLA is $60–80. Yeah, that much. And availability is super low. So PETmachine is like salvation there. You can collect garbage around and then create your own filament, which is like gold there. In Turkey, filament is not that expensive, but I used to live there for a few years, and I noticed that there's a lot of bottles on the streets. People just throwing away whole bottles, and I was walking around just collecting those bottles like a treasure. Maybe in Europe, especially in countries like Germany, for example, where they have this return policy. When you're buying a bottle of soda, for example, you pay small caption on it, like 25 cents, and then you put back to the machine, bottle to the machine, and receiving those 25 cents. So in this case, it's not that efficient and justified. But other first 2 examples I showed on the beginning, it's game changer. And using the occasion, I would love to mention about my project in Kenya. 3D printable crutches. They are fully 3D printable. This material is ASA. It's durable enough. I had to test few of the materials and choose best one that is not breaking too fast. So long story short, in Kenya and for example in many African cities, there were civil wars, and many people lost their hands, legs, arms, amputees, and they can't afford crutches. So we got an idea that we can print them. So the total cost of 3D printable crutches is about $8–10. Yeah, something like this. And to buy brand new crutches there is $150–200. So the difference is huge. Of course, they are not certified, but it's better to use not certified than not at all and crawling on the ground. So it's an incredible project. We want to print first 10 prototypes that will be tested there for a football team. Like people are disabled and they're playing football, and normally they just share few crutches with teammates. So we want to make them a big gift and 3D print them. And the next step will be creating 3D printed crutches with PET recycled filament. So just imagine, there can be a few groups of people, that one group is collecting PET bottles, second one is cleaning and preparing bottles, third one processing, and fourth printing everything. So I hope, I really believe we can do this someday and we can see people converting garbage into something that useful, like crutches. It will be amazing. This is my other project in Turkey, like I mentioned. I used to live there. People love cats a lot there. There is many stray cats that people take care of them. They feed them. They building small houses for them from old paint containers. People love cats there a lot, and there is a lot of stray cats outside. And I got an idea that I could do something good there as well, and use those bottles from the street to 3D print pet house. It's catchy name because it's like pet, PET house and pet house. So this is my second prototype. First one was a little bit too small. I will show you the pictures and videos. But this one will be much bigger. I didn't build it fully yet. Parts are still printing. So I hope this project will bring a lot of good things for cats in Turkey. For example, we can organize actions there, like collecting bottles, and for every bottle we can print one panel, because this pet house is made from panels. As you can see, here are the connections. So you connect single panels with zip ties. So we are not limited that much with a plate of the printer, because it won't be possible to print that big object on the printer. So we can print many smaller ones, smaller panels, and then put everything together and got the whole pet house. I told you a lot in a meanwhile, but strip is almost finished, so let's check our new filament. We winded some filament. It's almost over, and soon I will show you my second design. That obviously is Pet Welder and Mr. Winder, because a lot of people ask me, okay, I have one section of filament, I produced one section of filament, but what if I want to connect and print something bigger at once? And the answer is Pet Welder and Mr. Winder. Our filament is fully winded. We unlock the spool because it's removable. We slide out, and we can mount it in Pet Welder. Now I can install our fresh filament on the spool holder, secure it, and turn on the Pet Welder. On the other end, I'm installing the spool with already winded filament. It's a PET bottle filament. And now we can start the process. I'm choosing from menu the filament profile. In our case it's PET, but Pet Welder can weld as well PLA, PETG, ABS, ASA, and so on. Our custom profiles. I'm choosing OK. I will take off the cover to show you the internal. I'm loading filament from the left side. Now machine is calibrating the filament, because PET filament made from bottles is a little bit tricky. It has different diameter every time, a little bit. Now I'm loading filament from the right side. Now filament is welding on the middle, thanks to induction heater. Filament was compressed when you heard that brrrt. It was compressed, and joint. Now it's time for cooling. Now welded filament came out. I will show you the section, this welded section, under the microscope, so it will be much better visible. But before that, I will show you winding as well. So when filament is welded, the window popped out and it's asking us if we made inspection, if welded spot is made well. If it's okay, then we click OK, and winding is starting. So now I pull back a little bit of filament, like filament. Oh, here it is. I will cut it off to show you this section under the microscope. Oh, here it is. Like, the emitter here is a little bit larger than the rest of the section, but welding spot is really solid in my opinion. Let's check, let's bend it. It's not snapping, it's bending, so it's a good sign. So it won't just snap when we try to print it. So in this way we can produce the entire spool of filament. We can wind like 1 kilogram of filament and just load in our printer and print bigger objects, or many of them. I will show you what we can print from this bluish filament from the bottle. This is the benchy. It's like simple test print for 3D printer. So when you have a new 3D printer or you want to test your filament, you just print it to check the details, layers, adhesion, everything. So as you could see, my designs are very useful, very funny to build, that you can put everything together at your home using your own 3D printer, and they have really great educational aspect. My friend Javier in Chile, he wants to create a recycling station based on PETmachine and PETwelder and use it in a prison with prisoners, like educational classes. It's a great opportunity to develop their skills in manual work and recycling in general. He already started his classes with success, and I hope we can make the same in St. Vincent. I'm really happy that I could share my ideas and designs with you, and I'm really hungry for more, for creating more projects to make even bigger impact in the world, to make these positive waves all around. Thank you for your time, and I'm really honored to be part of this event. Thank you so much.